Right now, at this very moment, you think you are made of atoms, tiny solid particles that build everything around you. Your teachers told you this, scientists told you this. Everyone believes this. But what if I told you that atoms, the very foundation of everything you think is real, are not actually real objects at all? What if everything you were taught about the building blocks of reality was a lie? Look around you right now. Look at the walls, the furniture, your own hands. Everything seems solid, real, permanent. You have been told since childhood that all of this is made of atoms, those tiny, invisible spheres that combine together like microscopic building blocks to create every single thing in existence. Your body has trillions of them. The air has them. Even empty space is not truly empty because atoms fill it. This is the story of reality. We have all accepted atoms are the fundamental units of matter. They are real. They are solid. They are the ultimate objects that make up our universe. Except there is one massive problem with this story. It is completely and utterly false. Atoms are not real objects. They never were. And once you understand why, your entire perception of reality will shatter into pieces. Now I know what you are thinking. This sounds insane. How can atoms not be real? We have pictures of them. We can manipulate them. Scientists move individual atoms around to create images and patterns. We use electron microscopes to see their structure. We build entire technologies based on understanding atoms. So how can I possibly claim they are not real objects? The answer lies in quantum mechanics, the most successful scientific theory ever created and the most misunderstood. Because what quantum mechanics actually tells us about atoms is so strange, so alien to our everyday experience that most people refuse to accept it even when the evidence is overwhelming. Let me take you on a journey back to the early 20th century. Before quantum mechanics, scientists had a beautiful picture of the atom. Ernest Rutherford had discovered the nucleus through his famous gold foil experiment. He fired particles at gold and found that most went straight through, but some bounced back. This told him that atoms were mostly empty space with a tiny, dense nucleus at the center. Then Niels Bohr added electrons orbiting around that nucleus like planets around a sun. It was elegant. It was simple. It made perfect sense. There was just one problem. It was completely impossible. You see, according to classical physics, an electron orbiting a nucleus should not be stable. An orbiting electron is constantly accelerating because it is moving in a circle. And we know from James Clerk Maxwell's equations of electromagnetism that any charged particle that accelerates must radiate electromagnetic energy. That means the electron should continuously lose energy as it orbits, and as it loses energy, its orbit should decay. The electron should spiral into the nucleus in a tiny fraction of a second, but atoms do not collapse. You are not collapsing right now. Every atom in your body has been stable for your entire life. So something was fundamentally wrong with our understanding of what an atom actually is. Then quantum mechanics arrived and everything changed forever. Heisenberg discovered something that shook physics to its core. He found that you cannot know both the position and momentum of a particle at the same time with perfect precision. This is not because our measuring instruments are crude. This is not because we are not smart enough. This is a fundamental law of nature called the Heisenberg uncertainty principle. The more precisely you know where a particle is, the less precisely you can know how fast it is moving, and vice versa. Think about what this actually means. It means that an electron does not have a definite position and a definite velocity at the same time, not because we cannot measure both, but because both do not exist simultaneously. Reality itself does not contain that information. An electron simply does not possess those properties in the way we think particles should. Erwin Schrödinger took this idea even further. He developed an equation now called the Schrödinger equation that describes how quantum systems evolve over time. And what his equation revealed was shocking. Electrons are not particles with definite locations. They are described by something called a wave function. This wave function is a mathematical object that tells you the probability of finding the electron at different locations. If you measure it, notice I said if you measure it before measurement, the electron does not have a location. It exists in what physicists call a superposition of all possible locations simultaneously. It is spread out across space like a wave. Only when you perform a measurement does the wave function collapse and the electron appear at one specific spot. This is not metaphorical language. This is what the mathematics actually says. An electron in an atom does not orbit the nucleus. It does not have a trajectory. It exists as a cloud, a probability surrounding the nucleus That cloud represents all the places the electron could be found if you looked for it. But before you look, it genuinely is not at any one place. It is everywhere the probability cloud extends. Now, you might be thinking this is just a limitation of our knowledge. Maybe the electron really is at a specific location and we just do not know where until we measure it. Maybe there are hidden variables, deeper levels of reality we cannot access that determine where the electron actually is, even when we are not looking. Albert Einstein thought exactly this. He despised the idea that reality does not exist until you observe it. He famously said that the moon is there even when nobody looks at it. He spent the last decades of his life trying to prove that quantum mechanics was incomplete, that there must be some deeper theory underneath it that restores objective reality. But Einstein was wrong, and we know he was wrong because of a physicist named John Bell. In 1964, Bell came up with a brilliant mathematical test. He showed that if hidden variables exist, if particles really do have definite properties even when we are not measuring them, then certain statistical correlations between measurements must obey specific limits called Bell inequalities. But if quantum mechanics is correct and reality truly is indeterminate until measured, then those inequalities can be violated. Physicists performed the experiments. They tested Bell inequalities with photons, with atoms, with every quantum system they could get their hands on, and the results were unambiguous. Bell inequalities are violated. Hidden variables do not exist. Reality at the quantum level is genuinely indeterminate. Properties do not exist until measurement brings them into existence. This has been confirmed thousands of times in laboratories all over the world. It is not speculation, it is not philosophy, it is experimental fact. Quantum objects, including atoms, do not have definite properties until you measure them, and this means they cannot be objects in any meaningful sense of the word. An object is something that exists independently with definite properties whether you look at it or not. A rock has a position, a shape, a mass. These properties exist regardless of observation. But an atom does not work this way. An atom is a quantum system described by a wave function. That wave function contains probabilities for different measurement outcomes. But the atom itself does not possess definite values for position, momentum, energy, or any other property until you force it to by making a measurement. The famous double slit experiment demonstrates this perfectly. Take an apparatus with two narrow slits and fire electrons at it one at a time. Put a detector screen behind the slits to see where each electron lands. What happens if electrons were particles, little balls of matter? Each one should go through one slit or the other, and you should get two bright bands on the screen corresponding to the two slits. But that is not what happens. Instead, you get an interference pattern, a series of bright and dark bands across the screen. This is the signature of wave behavior. Waves can go through both slits simultaneously, interfere with themselves, and create this pattern. So each electron, even though you fire them one at a time, goes through both slits at once, not one or the other, both simultaneously. How is this possible if an electron is a particle, an object with a definite location? The answer is that electrons are not particles with definite locations. They are wave functions. The wave function spreads out, goes through both slits, interferes with itself, and then collapses to a point on the detector screen when measured. Before hitting the screen, the electron was not at any one place. It was in a superposition of going through both slits. Now here is where it gets truly bizarre. Put detectors at the slits to see which one each electron goes through. Watch the electron as it passes through. What happens to the interference pattern? It disappears completely. Now you get two bands, exactly what you would expect from particles going through one slit or the other. The act of measurement, the act of observing which slit the electron goes through changes the outcome of the experiment. Before you looked, the electron went through both slits and created interference. After you looked, it went through one slit and no interference occurred. Observation does not just reveal a pre-existing reality. Observation creates reality. This is not mysticism or Eastern philosophy dressed up as physics. This is what the mathematics predicts and what experiments confirm with absolute precision. We have done this experiment with atoms too. Fire atoms through double slits and they create interference patterns just like electrons. Each atom goes through both slits simultaneously. Atoms are not little solid balls bouncing around. They are quantum wave functions that exist in superposition until measured. And it gets stranger still when you consider entanglement. Take two atoms and allow them to interact quantum mechanically. Maybe they collide. Maybe they are created together in a reaction. Once they have interacted, they become entangled. Their wave functions merge into a single combined wave function that describes both atoms together as one system. Now, separate those atoms. Move them to opposite sides of a laboratory, opposite sides of a city, opposite sides of the galaxy. It does not matter how far apart they are. They remain entangled. Now, measure a property of one atom. Say its spin. The instant you make that measurement and get a result, you immediately know what result you will get. If you measure the spin of the other atom, not because information traveled between them, not because one atom sent a signal to the other, but because they are not actually two separate atoms, they are one entangled. Quantum system described by one wave function. Distance in space does not separate them. They remain unified at the quantum level. Einstein called this spooky action at a distance and thought it proved quantum mechanics was absurd, but we have verified entanglement in countless experiments. We use it in quantum computers and quantum cryptography right now. It is real. Two entangled atoms are not two independent objects. They are one quantum entity, and you cannot describe one without describing the other. This reveals something profound about the nature of objecthood itself. Objects are supposed to be separate, independent, localized things. But entangled atoms are none of these. They are unified across arbitrary distances. The boundaries between things dissolve at the quantum level. Quantum field theory makes this even more explicit. In quantum field theory, which is the framework that combines quantum mechanics with special relativity, particles are not fundamental at all. Fields are fundamental. Every type of particle has an associated field that fills all of space. The electron field permeates the entire universe. The quark field permeates the entire universe. The electromagnetic field permeates the entire universe. What we call particles are excitations in these fields. An electron is not a tiny ball of matter. It is a localized vibration in the electron field. An atom is a bound state of multiple field excitations. Electron field excitations orbiting around quark and gluon field excitations that form the nucleus. These are patterns in fields, not objects made of stuff. Think of an ocean. You can look at the ocean and see individual waves. You can point to one wave and say that is wave number 1 and another wave and say that is wave number 2. You can track waves as they move across the surface, but are waves really independent objects? No, they are temporary patterns in water. The water is what exists. The waves are just shapes the water takes for a while before dissolving back into the ocean. Atoms are like that. They are stable patterns in quantum fields. The fields are what truly exist, what fill all of reality. Atoms are temporary configurations of those fields. They have no independent existence apart from the fields. They are not objects in the fundamental sense. They are patterns, structures, stable excitations. And just like waves on an ocean can merge, split, interfere with each other, so too can atoms. Two atoms can fuse into one in nuclear fusion. One atom can split into multiple atoms in radioactive decay. Atoms can exchange particles and become entangled. They are fluid, dynamic, interconnected patterns and fields, hard, separate objects with rigid boundaries. This understanding is not just theoretical. Every piece of modern technology relies on it. Transistors work because electrons in semiconductors behave as quantum wave functions, not classical particles. Lasers work because atoms can exist in superposition states and emit coherent light when they transition between energy levels. MRI machines work because atomic nuclei have quantum spin properties that respond to magnetic fields in ways no classical object could. The computer or phone you are watching this video on exists only because engineers understand atoms are quantum systems, not little balls of matter. But here is what should really break your brain. If atoms are not objects, then nothing made of atoms can be an object either. Your body is not an object. You are made of atoms or more. Precisely, you are a pattern of quantum field excitations. Your skin, your bone, every cell, every molecule, every atom, all of it is patterns and fields. And those patterns are not isolated. You are constantly exchanging atoms with your environment. You breathe in oxygen atoms. You breathe out carbon dioxide atoms. You eat food and those atoms become part of you. You shed skin cells and those atoms leave you. The atoms that make up your body today are not the same atoms that made up your body 7 years ago. Almost every atom has been replaced. So what are you? You are not a fixed collection of atoms. You are a dynamic pattern that maintains itself even as the underlying atoms constantly change. You are like a whirlpool in a river. The water molecules flowing through the whirlpool are always different, but the whirlpool persists as a stable pattern. You are a pattern in quantum fields that has been stable for decades, but you are still just a pattern, not an object made of smaller objects, and it goes deeper. You are not separate from the rest of the universe. Photons from distant stars have hit your body and interacted with your atoms. Those interactions create quantum entanglement between you and those stars. You are literally quantum mechanically connected to the entire cosmos. The boundary between you and everything else is not a real physical boundary. It is a conceptual boundary we draw for convenience. At the fundamental level, there are no separate things. There is one unified quantum field, or actually multiple quantum fields overlapping and interacting, that spans all of reality. What we perceive as separate objects are just localized excitations, temporary patterns, regions where the fields take on particular configurations for a while. Does this mean nothing is real? Absolutely not. The patterns are real. The fields are real. The mathematics that describes them is real and astonishingly accurate. We can predict the behavior of quantum systems with precision beyond anything else in science. The energy levels of a hydrogen atom calculated from quantum mechanics match experimental measurements to more than 10 decimal places. No other theory in history has achieved that level of accuracy. Reality is real. It is just not made of objects. It is made of quantum fields, probability amplitudes, entangled states, superpositions. It is far stranger and more beautiful than the clockwork universe of solid atoms bouncing around that we imagined centuries ago. The solidity you feel when you touch a table is real, but it is not solidity in the way you think. You are not touching atoms. You never touch anything. What you feel is the electromagnetic repulsion between the electron clouds in your hand and the electron clouds in the table. Those clouds are not little particles making contact. They are overlapping probability distributions in quantum fields that repel each other through the electromagnetic force. The sensation of solidity is a macroscopic illusion created by quantum field interactions. We have been living in denial for over 100 years. Quantum mechanics has been screaming at us that atoms are not objects, that reality is not what it seems, that the universe is profoundly different from our everyday intuitions. But we keep trying to cram quantum systems into classical boxes. We keep drawing little spheres to represent atoms in textbooks. We keep talking about particles as if they are tiny balls. This has to stop. If we want to truly understand reality, we must accept what quantum mechanics is telling us. Atoms are not objects. They are quantum systems described by wave functions that evolve. According to the Schrödinger equation, they exist in superposition. Until measured, they become entangled across vast distances. They are excitations in quantum fields, not independent entities. Once you accept this, once you really let it sink in, you will never see the world the same way again. You will look at solid matter and know it is mostly empty space filled with probability clouds. You will touch things and know you are feeling quantum field repulsion, not solid objects. You will look at your own body and realize you are a temporary pattern maintained by the laws of physics, not a permanent collection of stuff. This is the true nature of reality revealed by our deepest understanding of physics. It is unsettling. It is counterintuitive. It violates everything our senses tell us, but it is true. And the sooner we accept it, the sooner we can move forward to even deeper understanding of what existence actually means at the most fundamental level. Atoms are not real objects. They never were, and now you know why.